Good day everyone, I'm Jubel Antoria will present a sanitary drainage and vent system design example in the chapter 14 of our book. Sanitary drainage and vent system design example. The following example convey a typical design approach for a 4-story apartment building used in the water supply design example chapter 13. A review of the drawing for the apartment show that each floor contains 2 bathroom groups and 2 kitchen sinks. Assume the project will be connected to a community sewer. In this project, it is assumed that there will be 2 plumbing stacks, one for each tier of the apartment. Now, we will discuss the 12 steps of sanitary drainage and vent system design example. First step is to sketch an isometric drawing of the drainage piping. The stack is located on the plan as shown in figure 14.12. The vertical stack in this sketch as shown in the figure 14.13 and beginning at the top floor. The fixture brands and the connection at each fixtures. Next, in the other 3 floors are stretches as shown in the figure 14.14. The vent stack is added from a point just below the bottom features branch to a point above the top of the features in the building drain. So as we shown in the pictures sketch. So this is the example. Next, the step 2 and the step 3. The next minimum trap size for each features is selected from the table point 1 and the trap size noted on the schematic pipe layout as shown in the figure 14.16. Assume the kitchen sink has a small PO or plumbing outlet plug. So next, step 3. The features branch in the first drainage pipe to be sized. The first portion of the branch to be sized is from the features farthest from the stack on the next features as shown in the 14.7. Begin by determining the features unit that this short piece of pipe will be served from the figure 14.17. In this problem, the branch serves a bathtub with a features unit value of 2 based on table 14.1. So as we shown in the screen, this is the sketch of the step 2 and step 3. Next, the step 4. Next, select the branch size to serve the bathtub from the table 14.2. In this case, the horizontal features branch size is being selected so to go that the column 14.2. Go down the column until the features unit is the same as or more than the amount being served in this case. 3 DFU, which is the greater than 2 DFU value of the bathtub. Now move horizontally to the left and select the minimum pipe size required. In this case, a 111/2 or in 38 or 40 mm. Now noted the information accumulated in the tabular form as shown. So this is the standard of use of the bathtub. So meron dito mga sizes at meron mga noted na kailangan tandaan ng number 1 tab is needs to 2 DFU. So the pipe size is the 1.5 inch or 38 or 40 mm. And so this is the example of the sketch in the screen. 14.14. Next, this is the example of the sketch of the 14.15 and the 14.16 building drain plan or sketch. Next, we will discuss the PIP step. DFU, the selection of the pipe that serve the laboratory and kitchen sink must be sized from the table 14.1. The number of the fixtures units of the kitchen sink served is 2 DFU, and for the laboratory is 1 DFU, for a total of 3 DFU. Referring to the table 14.2, the minimum pipe size is 11/2 inch or 1.5 inch or 13 or 38 mm. The maximum horizontal distance from the fixture trap vent limited to 5 feet or 1.5 meter. The accumulate in the formation in this listed is follow. DFU pipe size number 2 sink laboratory to branch 3 1/1/2 or 38 or 40 mm. So this is the standard sizes. So first in the table 14.5, the horizontal branch tabulation is tab to lab is 2 DFU, then the size pipe is 1/1/2 inch, and this to vent is 5 feet. Next is the KS lab to tub is 3 DFU, and the pipe size is 1/1/2 inch, and the distance is to the vent is 5 feet. Next, number 3 is the KS lab to tub WC. The DFU is 5, the pipe size is 2 inch, and the distance to the vent is 8 feet. And number 4 is KS lab to tub and W to stock. The DFU number is 8, and the pipe size is 3 inch. The distance to vent is 10 feet. And next, we will discuss the SI unit. And so as we discussed in the upper part, so this is the SI unit. The number 1 is 2 and 38 mm and 1.5 meter. Number 2 is 3 and 38 mm and 1.5 meter, and the number 3 is 5 and 50 mm and 2.4 meter, and the number 4 is 8 and 75 mm and 3 meter. Next, we will discuss the 6th step and the 7th step. 6th step, the section of the branch marked number 3 serves the tub, kitchen sink, and laboratory from the 14.1. Bathtub is 2 DFU, kitchen sink is 2 DFU, laboratory is 1 DFU. The total is 5 DFU. From the table 14.2, the pipe size is 2 or 50 mm, and add this information to the tabular form. DFU pipe size number 3 sink, lab, and tub, and 5 or 2 inch 50 mm. And the 7th step, now the last section is calculated and tabulated at this point. The branch services all the features which are the features group and the kitchen sink from the table 14.1. The features units are 1 bathroom group, 6 DFU, and a kitchen sink 2 DFU, total of 8 DFU. From the table 14.2, the pipe size is 2.5 inch or 65 mm. But since the pipe cannot be smaller than the large just picture trap or 3 inch or 75 mm pipe is required, or water closet 3 inch or 75 mm trap. DFU pipe size. Number 4 bathroom sink is 8 feet to 3 inches or 75 mm. Next, we will discuss the 8th step and the 9th step. With all branches tabulated and 14.5, transfer the size to the isometric sketch as shown in figure 14.18 because each floor is exactly the same. All of the branch sizes are the same, and all floors are noted on the isometric drawing. If any of the branches were different, the same procedure would be followed to determine the pipe size in these different branches. The 9th step is the stock size selected next because the stock handles human waste. It is a soil stock. The stock must be selected in a size for a total pictures unit that must be handled. As noted in the sketch in 14.19, each floor has a total of 8 DFU for an overall total of 30 DFU based on 30 DFU for tire stock. The minimum stock from the table 14.2 would be 2.5 inch except that the stock. And this is the example of the sketch of the 14.18. And next, we will discuss the step 10. The vent stock is sized next using the table in 14.4. It is necessary to know the maximum size of the soil stock left column in the pictures unit connected to the vent stock. The maximum length of the vent stock is noted in feet. The soil stock has already been sized and the DFU have been totally as 32 for this stock. The developed length of the vent stock is the length of the pipe required from the lowest point where it connects with the soil stock to the point where it is terminated outside the building, or as illustrated in figure 14.21. The next step is to determine the size and location of the main vent stock. The code requires that every building shall have at least one main stock. This main stock must be sized to handle the total pictures unit on the system. So we must remember always the code required that every building, I will repeat, shall have at least one main stock. This main stock must be sized to handle the total pictures unit on the system. So this is the example of the sketch of the 14.20. So we can find that, or we can review that in our book. Next, this is the tabulation stock size. So the floor is 4 FU8, and this is the pipe size. The plumbing code states that the main vent and vent stock shall be sized in accordance with the table and be not less than 75 mm in diameter. In addition, it states that the size of the vent stock must not be reduced all the way through the roof. So in this design, the minimum vent stock is 75 mm is selected. Code requirements also stipulate that the vent stack must be terminate no less than 6 inch or 150 mm above the roof of figure 14.22. And if the roof is to be used for more than weather protection, for example as a terrace or balcony, the vent stack must run at least 5 feet or 1.5 meter above the roof. Most code require at least a 3-inch or 75 mm vent through the roof. Ayan. So, we can review in the table, the right side or the left side. Next, we will discuss the 11th step. The next step is to size the building drain. The building drain must be sized for the total of the DFU connected to the point at which the main vent connected in this size. There are 2 stacks serving the building, which means the 2 stacks must be connected to the building drain. And sketch similar figures 14.23 help to prevent any confusion or possibility that staff may forgotten or on the sketch. And in tabular form, these accumulate features unit. Next, the step of the drain must be determined noted in the sketch. And 1.82 per feet or 14.4 mm per meter is selected. Building drain size are found table 14.3. In this design, the main vent is considered to be the end vent as noted in the pictures 14.24. So the entire building must drain size for 64 DFU. And so this is a sample of the 14.21 in the sketch in the right side of our presentation. Next, we will discuss the last step. In the 12th step, the plumbing drainage system has now been designed with the exception of the checking of location of the vent in relation to the features. As the features branch size were being selected, the maximum distance from the trap to a vent has also tabulated. In reviewing the features branch in the trap sizes, in the table 14.5, each of the tab, laboratory, sink, and traps can be no more than 5 feet from a vent, and water closet no more than 10 feet or 3 meters. A review of the floor plan that the total width and the bathroom is 7 feet or 6 inches, 7 feet and 6 inches or 2.25 meter. This means that the vent could be located in the wall near laboratory, be within the limits of all listed horizontal distance. If the features are spread out, one or more features are beyond the maximum horizontal distance, there are 2 options. First option, increase the size of the horizontal features branch, which automatically increase the allowed horizontal distance. For example, change the length 1 from 1.5 inch or 38 mm or to 2 inch or 50 mm, and change the horizontal distance from 5 feet to 8 feet or 1.5 meters to 2.4 meters. Many times in this the most economical solution. Next step is add more vent instead of trying to service a group or features with one vent. Perhaps a vent could be added to service any features that are beyond The allowable distance are variety of vent solution for virus group or of features is shown in the figure 14.25 through the 14.28. So this is the sample of the sketch, and this is the sample of the first option, and the example of the second option sketches. When the minimum size of the vent is larger than the waste size previously selected, the largest size must be used. The note of the vent requirement required on the schematic sketch and the plumbing drainage design is completed for this project. So this is the sketch of the A, B sketch, C and D and E, F to G. This is a sketch of the vent. Next, this is the sketch of the plumbing drainage of the 14.26, the 14.27, and 14.28. So we can review all of these in our book, in the chapter 14 of our book. Thank you everyone for listening.